Hello everybody and welcome to the 5th episode in this series where I teach you how to build a redstone computer. Last time in the 4th episode I taught you guys about how to store bits, and if you remember and if you watched the entire video, you recognize that little repeater circuit there in the background. If you don't, please go check out that video. It's really important for you to understand that material. But anyway, this episode I'll talk to you about how to add bits. So that's for the ALU component, if you remember from the first episode. Anyway, let's get started. So as usual, the components of this video are the 3 components: half adder, then the full adder. If you already understand a little bit of the ALU in a computer, you'll recognize these 2 terms. And then at last I'll show you my design, and I'll quickly go to the real computer to show you how I actually implemented it, to show you the real thing. So here you see a few circuits, but as usual I'll go back into Paint because Paint is just a lot easier to explain and show different circuits. And if I'm done, I'll show you how they work in Minecraft. So to start things off, we'll look to the truth table of the adder. If you watch the second video, you will remember what needs to happen. But for a quick recap, if both of the inputs, so these are the 2 input lines, A and B, this will be the carry line and this will be the sum line. If both of them are off, your output will be 0, and 0 you represent with 0, 0. Easy. If one of them are on but the other is off, in these 2 cases, then your output will be 1. 1 you represent with 0, 1. So that is the same for these 2, but this is the big difference, which makes the adder a whole lot complicated. If it's 1 plus 1, you get 2, and 2 you represent with 0, 1, 0, 1, 0. And where you can represent these 3 with only 1 bit, you need to have 2 bits to represent 2. This is in the carry line and will be carries to the next pair of 2 bits. So let's make the circuit. Here are the 2 input lines, A and B. Okay, the first line, if it's 0 and 0, the output needs to be 0. Not hard, you don't have to do anything. If it's not connected to anything, it will always stay 0. So easy. Next lines. If one of them is on, the sum line must be on. Okay, we can make an OR gate. So now what happens is, damn it, my mouse isn't working. I'm sorry, this needs to be an OR gate. With a bit of imagination you can see it. So what happens now, if one of them are on, the outputs will go on. Oh, damn. In the last line, they're both on, so the OR gate will go on, but the sum line needs to be off because 2 is 0, 1. Okay, that won't work. How can we solve it? Not too difficult. Instead of an OR gate, we use an XOR gate, so it will not turn on if both of them are on. Okay, let's construct that. Sorry, this is just some future planning. Okay, a X OR gate. Now, bam. So this is the sum line, and for the carry line, they always need to stay off, except if they're both on. We have a gate for that, the AND gate. So the two lines, and that's an AND gate, and we're done. I mean, we're kind of done. I'll show you in a minute. But this is a half adder, and we will get a full adder. But first I'll go into Minecraft to show you how to build a half adder for the actual computer. Okay, so now that you understand how to make the half adder in Paint, this is the design in Minecraft. Quite easy stuff, as you might see. It's not that big, you can definitely go smaller, but it's not big. So here are the two inputs, and these are the two outputs. This is the sum line, and this is the carry line. So what happens? The two input lines, these are the two different gates. So both gates, one of the input lines. This is an XOR gate, that's what we needed for the sum. And this is an AND gate, that's what we needed for the carry. Like you see, 0, 0, they both need to be 0. If I turn 1 on, the sum line turns on. If I turn the other on, same happens. And if I switch both on, the sum line turns off and the carry line goes on. Now, although this is not that big, we can definitely go smaller. So this is my design, the smallest I could come up with. I'm sure there are some wizards that can get much smaller than that, but I'm not one of those wizards, so this is the smallest I could. Here are the two inputs, and here are the two output lines. This is the carry line, and this is the XOR gate. The XOR line, so the sum line, so they're switched. These are the two inputs, and I'll quickly show you. One of them on, sum line off, on, but same, and both on. The other line goes on. How does this work? Like I said, talked to you about how I couldn't find a one-tileable XOR gate. That is very easy. This is kind of a one-tileable, but not really. Let me show you. First, this line. This is just another version of the AND gate with the two target blocks. It works on the same principle. So you power two redstone torches. They combine into one line, so that's this line. First redstone torch, second redstone torch. They go together into this piece of redstone dust, and the signal gets inverted again. Now if you see, this sticky piston goes into the other circuit. Why? Because here there is just an OR gate implemented, not an XOR. But because it was so hard to get an XOR that's really small, I just used the AND gate. So what this does is this line goes on if either one of them are on, but if both of them are on, so with the AND gate, this sticky piston gets extended and the signal can't go through. So what that means, this line will go on if either one of them are on, but the signal will only go through if they're not both on, because AND gate, this is an AND gate, and that's when you get an XOR gate. So that's how the system works, but we're not done yet. There is a problem. If you go to the next row, you'll have the two input lines as usual, but you'll also have the carry line of the previous bit. And that's a problem, because now you have to add 3 bits. And then things get a little bit more complicated. So let's go back into Paint. It's actually not that hard. You'll quickly get the hang of it, but I need to show you. If you have 3 lines, things get a lot more complicated. Luckily, we can stick to our 2 output lines, so that doesn't need to be changed, but we have a third input line, you see right here. Okay, this section, first floor, you already saw, that's from the half adder. This you didn't. Let's go through it. 1, 0, 0. 1 plus 0 plus 0 plus 0 is 1. So we need to draw a 1, and the output needs to be a 1. So again, 0, 1. Here, 1, 0, 1. Same here. 2 1s, a 1, 0. That's 2. 2 is 1, 0. For both of them. Now, the last line, they're all on. 1 plus 1 plus 1 is 3. 3 is 1, 1. So that needs to be a 1 and a 1. For first 4, we can actually stick to our normal half adder without the carry line. Okay, this is bad. This is really bad. Okay, bam, bam, line, half circle, and 2 lines. So XOR gate and gate. Now, what needs to happen? First, let's look at the sum line. So if the carry line is off, it just can stay normal. But if you look at it, the sum, if the sum line is off and the carry line goes on, the sum line needs to go on. That's in both cases true. These are both 0 and these are both 1. And if the sum line is on, the output lines will need to stay off. So we basically need to invert the line if the carry line is on. Now there is actually a circuit for that. I mean a circuit. It's just a gate, the XOR gate. What this will do is it will invert the line if the other line is on. Let's look at an example. Imagine your input line is 0 and this also stays 0. If this is the line that controls if it needs to be inverted or not. It doesn't really matter, you can also swap them around. 0 and 0 needs to stay 0. If this one becomes a 1, 1 and 0, it needs to become a 1. I won't draw it because it's annoying. If this goes into a 1, however, this goes back to a 0. 1 and 0, that's a 1. But if it also goes to 1, then it's 1 and 1, XOR gate, back to 0. So we can use an XOR gate. Here comes the carry line, okay, and an XOR gate, and we have our sum line. This is our sum line. What needs to happen for the carry line? Okay, so when is it on? It is only off if both of the inputs are off and the carry line is on. It's also still on if if both of the input lines are on, of course. Now, how can we make this work? Well, it's not that hard actually. If you also take our carry line and we combine it with our sum line, and this line, it's a little bit messy, and we do an AND gate. What will happen now is, so this is the sum line actually from this line, so these four and these four, this is the ones you combine. It needs to go in this case 0 and 1 needs to stay off. 1 and 1 goes on, 1 and 1 also goes on, and 0 and 1 goes off. And this is a 1, and but this needs to be a 1. So no, it won't work. Except this one is already on if both of them are on. So what we can do is take the AND gate from here, from if they're both on, and just run them through an OR gate, and we have our carry line for the next line. So that's the entire full adder. Now, if you're smart, or if you just see it, you can see that over here and over here we actually have two half adders in a row. So what this basically is you have a half adder. So you have a half adder with the two inputs. Then you have the two outputs, the sum and the carry. So this is the sum in this case. Oh no, sorry, this is the sum. The sum and the carry you run through a half adder again. So this is a half adder, and this is a half adder. The AND gate you just run through. Then this is the sum again, and this is the carry. You run those through the last gate, the OR gate, and it's on. And that is the full adder. That's it. It's just two half adders in a row with an OR gate at the end. How do you need to build this in Minecraft? Let's quickly get to it. So now that you know the whole full adder, we don't have to go anything bigger than that. I can show you this design in Minecraft. As you might see, this design is quite bunky. I didn't do anything for space, and you might recognize here the XOR and AND gate from there, exact same, and here again XOR and AND, so the two half adders, and here you have the OR gate. Quite easy. So these are the three input lines. This is the carry line from the previous set of bits, and these are the two input lines. Now here you have the carry line, because this is an AND gate, this is an AND gate where they get ORed, and this is the sum line. This is from the XOR gates. Let's quickly test it. I'll turn one on. The sum line goes on. Let's test them for those two, all three. That works. 2 on. Yes. The sum line goes on. I mean the carry line. Alright. And if you turn all three on, they get both. They turn both on. But this is really big, so we can go a lot smaller. Here we even see better the two different half adders. So this half adder and this half adder. So it's just these two half adders in a row, but the only difference is there's a line going underneath the second half adder and merging with the output of the AND gate. Now, quick note, And my actual computer, I don't invert it and invert it again. That's not very efficient. It's just so I could put uh, the lamp here. But it's very elegant to show. It works the exact same way, and everything should go as planned. Yeah, I already tested it, so well, quite easy. Even if you understand the half adder, it's not very hard to understand the full adder. So anyway, thank you guys for watching to this episode. Hope you enjoyed it and hope you learned from it. If you have any questions, leave them down in the comment section. Next time, I'll actually tell you guys how to, or teach you guys how to build the entire LU. So not just the adder, the input, the output, everything. And now you'll have complete control of the first component of the entire computer. So, if you enjoyed the video and if you're looking forward to the next one, please like and subscribe. It would really make my day. Have a good day and bye. Fucking Christmas.